The net charge, or charge distribution of a system, can change in response to the presence of or changes in the net charge or charge distribution of other systems. And the net charge of a system can change due to friction or contact between systems. So for example, if you consider your hair as a system and you rub a balloon on your hair, then electrons get transferred from your hair onto the balloon, and the net charge of your hair will be positive. So therefore the balloon will be attracted to and stick to your hair due to electric forces resulting between the attraction of opposite charges. So another example is if you wipe a glass rod with a silk cloth, the glass rod loses electrons to the silk cloth and gains a net positive charge. Now, induced charge separation occurs when the electrostatic force between two systems alters the distribution of charges within the systems, and this results in a polarisation of either one or both systems. So for example, if you bring this positively charged glass rod next to a neutral conductor, then this will attract electrons towards it, leaving behind a distribution of positive charges. So effectively this system, being the conductor, has been polarized, because an electric field will be generated due to the separation of these charges. So this is basically induced charge separation, which, as we saw, can occur in neutral systems. So in general, any change to a system's net charge is due to the transfer of charge between a system and its surroundings. So therefore charge is conserved and the net charge is constant. So effectively when the glass rod loses charge to the silk cloth, this is basically a transfer of charge. So charge is not created or destroyed, but transferred between systems. And as we saw, the charging of a system typically involves the transfer of electrons to and from the system. So in these two example cases, and the net charge of a system will be constant unless there's a transfer of charge to and from the system. Consider this glass rod, which is positively charged. So for example, if you wipe it with a silk cloth, it loses electrons. And now suppose we have this conductor sitting on an insulator. And remember that the electrons or charge carriers in conductors are free to move around. So if we bring the glass rod near the conductor, it's going to draw electrons towards it. And that leaves behind a positively charged region. Now if we bring these two conductors into contact, then this positively charged region here is going to be even further away. And now when we separate these conductors, this one will have a net negative charge, and this one will have a net positive charge. So we've induced these charges on the conductors, and this is called charging by induction. Now consider this rod made of rubber, which is negatively charged. So for example, if we rub this with a piece of fur, it'll gain electrons from the fur. So again, if we have this conductor sitting on an insulator, this negatively charged rod will repel electrons this time. And that leaves a positively charged region near the rod. And now we can ground this conductor by connecting a wire from it to a much larger and approximately neutral system, such as the Earth. So therefore in this case, we provided a pathway for these electrons to escape the conductor, so they'll go even further away from this negatively charged rod. And now if we cut this wire and remove this negatively charged rod, then these electrons will have no way to get back. So therefore that leaves behind a net positive charge, and we've charged this conductor by grounding it. And note that this excess charge redistributes evenly on the surface of the conductor under electrostatic conditions.